This broadcast is made possible by F&B Namibia. This lesson is provided by Eduvision with the support of sponsors.
I explained that to you. That's usually a little bit difficult. As I say, next year we're going to do a lot more, but the answers are on your calculator. No, man. Okay, so this is then trigonometry. There. Okay, now we are busy with trigonometry and this is extended. So Albert has a question and asked that we explain number 1 again. So let's go a little bit back to number 1 then there. So this is the typical graph of the cosine rule. It's between 0 and 360 degrees and the amplitude is between 1 and -1. That is the amplitude. I think you learned that in physical science. Is there anybody who just have business? Yeah? No. You have business. Okay, because usually they didn't pick it up. So now they say this is the function y is equal to cosine x. Y is equal to cosine x. And it ranges between 0 to 360, but then they also say this is 2.5. So we said the two places that we have here is there and there. That is the two places that you have where it's more than or between 0 and 1/2. But they also say it must be between 90 and 360 degrees. That's why this part is not in now. It's not in because that's less than that. So now we are looking at that place there. Now, if you look on the graph, and I think we all agree on that one, that the first one there is 270 degrees, because that's where you can see it there on the graph. But now we have to find that other point, Albert, and that is what your question is. So what do you say is that point there? Yeah, here, that point there, because that's between the two places, that's the range. Okay, why do you say that? Okay, what I think what we should do is, if you press your calculator, I think he's right. If you press your calculator, cosine 1/2, what do we get? 60 degrees. So that's why he says, and remember now about cast and the butterfly story, this is where cosine is positive. Butterfly story, how do I get this one? 360 minus 60, and the answer is then 300 degrees. Yeah, but that doesn't really matter now. That was Albert's question yesterday also. So that's why we rather use this method of cast with a butterfly story. That's what he said yesterday. It's not precisely in the middle. I cannot just assume that. Okay. So what we said is I press my calculator, cosine 1/2, second function cosine 1/2, then I get 60 degrees. And then according to cast, cosine is positive in these two quadrants. Butterfly story, how do I get that one? 360 minus that 60, and that's how I get the 300 degrees then there. No, that's what they say. Look, they say for which cosine x is 1/2. They say it there. That's why I use it. We worked with sine 50. Michelle, please. Sorry? Because they gave you the sine 50, they gave you the degrees, so that's why we didn't calculate it. They gave us the 50 degrees. They gave us the 50 degrees. Okay, so now we're busy with question 3. question 3. Okay, it looks like this. What also comes in here is bearings, and we also have to look at that. That one is 30 degrees, this one is 50 degrees. Now, remember about bearings. It is always north clockwise. You always work north clockwise. That's why the Titanic bumped into an iceberg. They didn't follow the rules. And then you also look at from. The from angle is the one that you are looking at. And the third thing is you have to give it in a 3-figure bearing. You learned that last year or in grade 9 already. I think you learned that there. Right, so the question is now, a ship sails from the harbor H on a bearing of 30 degrees. There it is now. To B. There's point B. Remember also that your north lines are parallel. They are parallel then there. It then changes course to sail to C and returns to H. So you've got an isosceles triangle there. Calculate the bearing of H from C. Now, if we have to calculate the bearing, this is what we want. That is the bearing that we want there. Okay, so what will it be? Okay, remember what I said, these lines are parallel. So if this angle is 80 degrees here, what will that one be there? No, the north lines are always parallel. Yeah, that's right. But we can just work now with A and C. Yeah, you can calculate it like that, which makes it 65 and 60. That's one way to deal with it. But now, look, what I actually need is this angle, because then I can say it's 360 minus that angle. Then you get the bearing straight forward. So can you see that this is co-interior angles? So if this one is 80 here, it means this one is going to be 100 there. So then the answer is 260. The bearing is 260 degrees. And then the bearing of C, why we can't do this one is because I still need this one. You don't have that one. So that's why you can't just, I don't know how you come to 295. Okay, so what you're saying is this whole, yeah, that's right. This whole angle here is 100 degrees. So the small angle there will not be 100, but 35 degrees. Okay, so sorry, this one is wrong. Janus, you are very sharp today. So 360 minus 35 is what? Janus? 325 degrees. No, that's fine, because it's 360 minus that one. This is the bearing that we want, north clockwise. So that's why I say you just need that little angle to be able to subtract it there. No, they say H. Oh, wait, I'm totally wrong, because they're asking H from C. I was taking it as B from C. So I'll have to find, actually what I need is this angle here. And this one is alternating with this one, isn't it? So this one is 80. So then it is 180 plus 80. Okay, so this one is B from C, and this one is H from C. Sorry, I misread the question, and can you see I put an A there instead of an H? Because this is 180, the straight line here is 180, and then I add that extra 80 there. This is turn your paper like this, then you can see it's out. This is parallel lines, and this one is 80, so the other one must be 100 degrees. It's parallel lines. Your north lines are parallel here. Yeah, then you're alternating. alternating. Okay, now I swap the two questions. So actually this is A and this is then B's answer that we got there. That was B's answer there. Yeah, the answer here is 260. There, 325. Yeah, that I did the first one at the top. I swapped it. So now we're looking at question 9. This is a very nice question. A, B, and C are 3 ships at sea. Their positions are shown by the triangle. C is due east. That means it's a 90-degree angle there. That's important. And A is on a bearing of 220 from B. So explain why angle ABC is 130 degrees. So you need there to say something about 220 degrees minus the 90 degrees, that due east. That's what we need to see, that it's due east. And that's then how you get the 130 degrees. Due east at B. C is due east of B, so there at B is the 90 degrees. There's the 90 degrees. Then that we say, giving your answer to 3 significant figures, calculate AC. Now, if you look at the picture, AC is the third side, isn't it? So I'm going to say that AC squared is then equal to 12 squared plus 17 squared minus in brackets 2 times 12 times 17 cosine, and which angle are we using now here? 130 degrees. The 130 degrees. What? Sorry, I've got 2 questions at the same time. Yes? I repeat again. Due east means 90 degrees. They say there at the beginning, C is due east of B. So that's why the angle at B is 90 degrees. No, you cannot, because it's not a right angle triangle. That's the point. It's not a right angle triangle. So this is the 90 degrees because C is due east of B. C is due east of B. That's the point there. Okay, so now we're busy with Pythagoras here, and it's then going to be, okay, you can give me the value. What do we get? 12 squared plus 17 squared is? The final answer. Okay, you can give it to me. Sorry, let me just write it down. 69.26. Okay. This is now the combination. If you've calculated everything. Remember, can you see cosine is obtuse, so it will be a negative times a negative. Hey. And then AC, you still have to root it to get the final answer. Albert, what is your answer? Albert, I've sent you that paper which stayed here on the table. So why didn't you do your homework? We cannot take maths higher level if we don't want to do our homework. You'll have to go down. I'm giving your names to Mr. Shaw. You're going down. Yes? 26.4. Yes. That's the correct answer. Right, then the next one is now number B2. B2. So this time they say BCA. And in this case, I will use the sine rule because you've got opposite sides and opposite angles. So we say sine C over which one side is opposite this one? The 12. And then it is sine 130 degrees. And then actually, it's now very important, Abigail, give me that one, but you must use unrounded information, not the rounded one. You're going to get different. 20 point? What did you have? Yeah, but I need more. You need 26.4 what? Okay. At least. Yeah, but listen what I'm saying. You need to use the unrounded one. So get used to write down the unrounded one, at least to 5 significant figures, and then you round off in your final answer. Oh, so the 4. Yeah, but this you're going to get a different answer then in the next step, and you're going to lose marks. You'll have to. Yeah, that's right. That's right. Okay, now second function C, remember it was cross multiplication here. So sine C is then 12 times sine 130 over 26.36. Now I need to get an angle, second function sine. It's an angle, second function sine. Albert, kry uit jou calculator. That's the B2. Yeah? Because this is how I'm going to do the calculation on my calculator. I'm struggling to get answers from you. That's why I'm showing. But then, yeah, but second function sine now because I want the angle. So that's the answer there. 20.4 degrees. Second function sine, Koros. And then the last one is then the bearing that we are dealing with here. The bearing of A from C. Now again, if we go back to this, no, to the next sketch. Yeah, I just wanted to look at my sketch again. A from C, so it means the north line is now at C. We've calculated this C there. So what would it be? So I was just looking at the picture actually. So yeah. So there at C, this is the north line. So this is what we want to calculate. Now A from C. Okay, it's A from C, so it's there. That one. That. So this one is now 20.4. Where do you have the 90 there? So I need to get this little one here. Yeah, or 270 minus that one. So actually you can say 270, I think this is the shortcut, minus 20.4. Okay, but look at it. Bearings is 3-figure bearings, no decimal places, so it will be 250. That's the bearing. No decimal places there. I don't need that one. No, north clockwise. This is what I need. This is the bearing. So this is 270 at that point, and I just subtract that one. That's how I get to that one. Right, the next question is then question 5. Yeah, the bearing. Now, yeah, then you'll round down. Yeah, then it won't play a role. Right, the next one is now number 5, and this is again a right angle triangle. So look at it, because you must be able to work with everyone. Right angle, so that's the first question. Is it a right angle triangle or not? Now write down the value of tan A as a fraction. So Johanna, what did you say will tan A be? Now I think I said this one as well. Right, let's do that one. So look at the picture, Johanna. What would you say is tan A? What is tan? We did it last year. So the ratio is 5/12. That is the tan ratio. Now at B, they say find the value of 2 tan A over that one, giving your answer as a fraction in its lowest terms. They don't want the angle. They just want the fraction. They don't ask the angle. So then I can say 2 tan A, so this is tan A over, and then it is 1 minus 5/12 times 1 plus 5/12. They want the question as a fraction. They don't want the value of the angle, and they don't want decimals. So if I calculate this one now here, then it will be, it's nou is weer te hoog. No, The value is 5/12. So this one is going to be 10/12 over, what is 1 minus 5/12? 7/12. And what is 1 plus 5/12? 17/12. Okay? And now I just have to deal with it as a fraction. Your final answer. Yeah. So that part you can do on the calc, but it must be as a fraction. This is how they asked it. This is how... But I don't want the angle. That's not the question. They want you to do it like this. This is what they want. Okay. Now, the homework is now number 6 and 7. And then we're going to skip that number 3 at the back because that's low-key. And we still have to do those constructions there. So I'm going to leave that one out. So I want you to do 6 and 7 for me. Albert, you as well. Okay, will you stop the recording? Okay.
This lesson is provided by Eduvision with the support of sponsors.
Right, so today we're going to look at the cosine rule. And this question is in every paper now, from now on, every test, every exam, you're going to get the cosine rule because they want to know that you can do it. So the rule says a squared is equal to b squared plus c squared minus, I like to use those brackets there, bc cosine a. Now, what you have to see first is that the side that you want to find and the angle correlates. That's the one that you're going to place there. The other thing is that where do I find them? And this is then the triangle ABC, and the small letters is opposite those angles. When will I use the cosine rule? When you want the third side. It's about the third side. So every time when you want that third side, this is when you're going to use the cosine rule there. So I'm going to do one example for you now on the board. Okay. Right. So let's look at this one. 7, 9. This one is A. So that is the side that I want to calculate. You don't need to write it down. Let's just do this one together and then on the board, and then I'll let you do some of them. Yeah, 50 degrees. Okay, so now I have to use this rule. And the quickest way to learn this is just to write it out every time. Just write it out every time. Or as I said, make a poster and put it up there where you work, because then you pick it up very quickly. So this is what I'm going to do. A squared is equal to b squared plus c squared minus 2bc cosine a. So in the next step, I'm just going to substitute now. Okay, so a squared, this is what you want to calculate. So b squared is now going to be 7 squared plus 9 squared minus, in brackets, 2 times 7 times 9 cosine, and what is the value? So a squared is equal to, so the sides are now 7 squared plus 9 squared minus, in brackets, 2 times 7 times 9 cosine 50 degrees. So all that I've done now in my first step is to substitute all those values in there. Okay, now I would like you now to press your calculators together with me. And this sum counts 4 marks. So it's worth to put those steps in and not just go for answers, because otherwise everything is wrong. So come on, 7 squared plus 9 squared. I want you to do it step by step at first. So it's 130. So 130 minus, right, now we press the calculators, 2 times 7 times 9 times cosine 50. Press your calculator. 2 times 7 times 9 times cosine 50, 80.99. 80.99. Okay, so in the next step, we're going to subtract this 2. So what is 130? Don't round off too soon. You're going to round off in a final one. So here we must actually keep 549. Okay, and eventually I want A. I want A. So you have to write it like this. You can't stick to A squared. And to get that, we need to get the square root of this one. So 7 point. Okay, 3 significant figures, sides to 3 significant figures. This is what we're going to do. Okay, so the first one we're going to do together. We're going to do this one then together. Look at the picture there, but I'm also going to draw it so that we just see it. 2, 3x and 140. 2, 3x and 100. Okay, so the first step So first one is substitute that formula, but let's first write down the formula. What is the formula? A squared is equal to b squared plus c squared minus 2bc, now bc cosine A. It doesn't matter. Don't bother to figure that out every time because sometimes the triangles have numbers on the vertices, but this time it doesn't have. So it doesn't matter which one is B or C, but the one that we want to calculate now is X. So if we substitute now, we're going to say X squared is equal to. So it's the two sides and the included angle that you work with. So it doesn't matter which one is B and which one is C. So that is not a stupid question, Jean-Pierre. That is very important there. So now it will be 2 squared plus 3 squared minus 2 times 3, and it is then cosine 140 degrees. Just wait, we're going to do it step by step. As I say, it counts 4 marks. Don't just write the answer, because if there's one mistake, there's no marks. You get no marks at all. The first method mark is for the substitution that you will get. Okay, so, but it's now in the first place important that we will substitute correctly. We need to substitute correct. So what is 2 squared plus 3 squared? 13. Minus, why is there a negative now? Yeah, okay, that will eventually be, but why is there now a negative? What is the value that you get? Negative? Okay, actually 5 significant figures here. Hey, why is it a negative this time? Look there, the angle is obtuse, and if I take you now back to what we did yesterday with cost, can you remember cost? So we said here is the obtuse angles in quadrant 2, and here sine is positive, but it means cosine and tan is negative here. So that's why that negative is very important there. So now you will say 13 plus 9.19. 13 plus 1, it was a acute angle. The angle was 7, the example that I took was 50 degrees. So it was an acute angle. Okay, but a lot of learners think something is wrong and then they throw that negative away. That's why it's very important there. And then in the last step, we get the square root now of 22.19, which will be 4.71. Be careful for premature rounding. So we must, here you actually need to give it to 5 significant figures. Otherwise, we're going to round off prematurely. Right, now we're going to do, and now I want you to do it a little bit more on your own, is now number B. First, write down the formula. 6, 10, 95. And this is what we want to calculate. Why do I use the cosine rule? Third side. Okay, so it's the third side that I want. That's why I'm going to use the cosine rule. What does the cosine rule say? A squared is equal to b squared plus c squared minus 2bc cosine A. bc cosine A. Substitute now. I want you now to substitute. Okay, so if we substitute now, it is x squared, which is equal to 6 squared plus 10 squared. Can you see? It doesn't matter there is Jean-Pierre, which one is first and which one is second. That won't change the value.